Hey folks, so in this video, I've kind of the last two areas of system calls to talk about, which is communication and then protection. So communication. Communication for us basically is talking all about how do processes communicate, right? So I have an operating system that's running, there's different programs running at the same time. How can those cooperate with one another, right? How can I pass information from one to another, right? Obviously, you can picture, maybe you're doing something like running a web browser, you want to print a page, you need to go and click print. Somewhere on there, right, there's the idea that your browser needs to pass information to the printer driver, right, to then go to the printer, right? So I need to hand something from one program to another, right? That's what we call inter-process communication. So how can we support that? So we obviously, right, behind the scenes, we have a bunch of system calls to support that. There are two overall mechanisms for doing this, right? One is called message passing, the other call is called shared memory. So I have my little diagrams here on the screen so we can talk through those. So the basic idea, right, of message passing is that, let's say, right, I have like two programs running, right? So I have, P1 and P2. P1, is for example that browser, it wants to print. P2 is a printer driver. I can basically send a message from P1 to P2, right? So you can see this arrow over here on the screen, right? So basically P1 makes a call, right, to this other process and says, so here's a piece of information, right? So then I get something on the other end. P2 can act on it. It can send it to the printer, okay? And that's what we call message passing. So the idea, right, is that my P1 is calling a message, right? So it's a specific function that says, okay, I'm going to send it to this person, and it's going to have this contents, and it'll go to this person or this process, right? And they'll receive that data, right? That's the message passing model. And we'll talk more about this later in the course. The other version of this is basically a mailbox version. So that's what I'm showing over here. So this is basically kind of normal message passing. These top two examples here, right? I sent two messages from P1 to P2. The other way I could do this is with a mailbox, where basically I go in this process that's running, right, and I basically, I go to the mailbox and I leave a message there, right, and this message is going to be, has a recipient, right, P2, but I'm leaving it in the mailbox. I'm not going to P2 directly and give it to them right in their hand. I'm just going to leave it for them in that mailbox, right, and then later on, P2 will check in that mailbox, and it'll pick up that message that it maybe has left for it. So those are two different models here, right? And a lot of times, right, what this may end up being, right, is this may end up being, something that's synchronous over here versus asynchronous over here, right? So, like if I have P1 and P2 and they're communicating directly, then probably one needs to wait for the other, right? And they'll have to sync up, right? One will have to be ready to send, one will have to be ready to receive, and then the communication will take place. Versus in a mailbox model, I can kind of just leave something, right? P1 could just leave something and then move along, right? So it'll be more asynchronous looking. All right, so that's our message passing model. And you can imagine, right, we'll have system calls to implement this stuff, right? So we'll have basically a send and then a receive, right, on the other end, right? Those will be our typical system calls for implementing message passing. The other alternative we have to do communication is with shared memory. So shared memory looks more like this, and I have my P1, I have my P2 again. And by the way, since you see on the screen, I have this T0 thing here. Basically, that says that time, right? So time goes down, right? As my program runs, it does this and this and this. Okay, so memory pool here, right? The idea basically is that there is going to be some memory allocation which both P1 and P2 can access, right? So instead of sending messages, making basically calls to one another, they both have basically this one huge array and both of them can write to it, right? So there's basically this array, right, and it's really huge, right? And there's some special commands we use to basically make that piece of memory available, not just in the parent process that created that memory, but also in the other one, right? In for example, P2, right? All of a sudden P2 can access a variable that's inside of another program. And so the idea there, right, is that basically my processes can communicate because it's like, well, P1 can write to this thing, and then P2 can read from that location, right? So P1 writes, P2 reads, right? Or P2 writes, P1 reads, right? They both have kind of the same variable that they can change at the same time and use that, right, as a communication scheme. Okay, so just as a real quick note here, you can probably guess this, right? But this is basically going to be fast, because it's just an array, right? People can just write to that memory, whereas this is slow. You need to package up a message, right? A message in a bottle, if you would, right? But then over here, right, I could say this is maybe, a little bit safer, right? Programs aren't directly tinkering with one another, whereas this is unsafe, right? Because the issue there, right, is that you can imagine what happens if the programs try to write to the same place at the same time. Then there's going to be a disagreement. Whose answer do we put in that shared memory pool at the end of the day? Hard to tell, right? So this is faster but more unsafe versus message passing is slower but a little bit safer. All right, so those are our communication mechanisms. Last note here, real brief, is about protection, right? So what do we need for protection? Basically, I guess I'll turn this over to you guys. This is my question here in the slide deck. What type of system calls do you think would be necessary in terms of protection? So what do you guys think? Well, there's a bunch of different answers to this, right? Kind of some typical ones are going to be anything dealing with kind of rights, right, or access rights. So let's say I have a file, right? I need to maybe control, is this executable or not? Does this belong to this user or not? Can this user open this or not? Those are all things that should be kind of highly protected. Those are going to be good candidates for system calls because that's something that only the OS should have basically permission or privilege to handle, right? To give access or to remove access to these things. So stuff like that. So basically file access things, hardware access things. You can think about networking, right? Do I need to guard this port or that port? Those type of things are going to be fair game for any sort of system calls having to do with protection. All right, so that's all I got for this video. In the next section of the course, we'll start going into the different architectures used to actually implement operating systems.